Welcome back to another notes video. I'm Miss Asmus, and today we're going to be learning about atomic structure. So we're mainly going to go over what an atom is, what the different parts to an atom are, and then how those different particles within an atom change its identity, as well as how we use different notations to talk about atoms. So we recently did this Build an Atom lab where you were able to add protons and neutrons and electrons to an atom. So you would just drag these protons in, the neutrons in, and the electrons in, and they would arrange themselves into the shape of an atom. Then you could see how the net charge changed, how the mass number changed, and how the element changed. So think back to when you did that lab and got to view it, and where those different subatomic particles, we call them, since they are smaller than an atom, how those different subatomic particles impacted the identity of that atom. Here we have a neon atom. So we can see that the center, which we call the nucleus of this atom, has protons and neutrons in it. So protons and neutrons make up that nucleus, that center of the atom. Then surrounding that nucleus, we have electrons, which are in blue. And so electrons are in a field or a cloud surrounding this nucleus at different energy levels. We also see here on the right, we have the identity of the element that this atom is of, which is neon. Then below that we have its net charge. We have protons and electrons evening each other out. These pluses and minuses are the same, so it has a neutral charge or no charge. And then it has a mass number of 22. So what do those different properties mean for this atom, and which of these subatomic particles make those properties true? So here are some questions that you can discover from that lab. We learned the charge of the protons, neutrons, and electrons. So protons are going to be positive. They will have a plus charge. Neutrons are going to be neutral, like the name would show, so they will have no charge or zero charge. And then electrons are going to be negative. So they will have a negative charge. So what about the mass of this atom? Well, when we added protons to this atom, they changed that mass number. So protons have a significant mass. So we're going to call this, when you added one proton, it added 1 to that mass number. So it is what we call 1 atomic mass unit. So it had a significant mass relative to the full mass of that atom. Then neutrons, they also added 1 to that mass number. So those are also 1.0 atomic mass units. And electrons didn't add anything to that mass number. So they do have mass, but it is much, much smaller than 1 atomic mass unit. So since it's 0.0000, we are going to just write that it is 0 atomic mass units, since it isn't significant. All right, then the last question, where are the protons, neutrons, and electrons located? We discussed that in our last one. Last slide, we saw that the protons and neutrons were located in the nucleus, so that's center. And the electrons were located in the electron cloud, or the electron field, surrounding that nucleus. In our lab on Wednesday, you got to build atoms based on their identity. So all you knew is what element it was and then what that mass was. And so you got to experiment to see which of these protons, neutrons, or electrons you could use to make each of these atoms be neutral in charge but have that mass. So we'll be going into more today of what that mass tells us and how we can find that on our own. So we'll be going through this note catcher for today, so make sure you have that downloaded so you can record the information in this lab so you can look back on it later. Here is a copy of that chart that is also in your note catcher. So we already went over 3 of these things: charge, mass, and the location. So pause the video, see if you can add those into your chart on your own, see if you remember them from the lab and from the past part of the video, and then we'll go over them together. So hopefully you paused that video, that you had some time to think through those charges, masses, and locations, but let's go over it now. So we already talked about the charge of a proton being +1. It has a mass of 1 AMU, and so the symbol for a proton is P, so it starts with P, and then plus, because it has that positive charge, and that is located in the nucleus. Then we have neutrons, which have a charge of 0, a mass of 1 AMU as well, and then their symbol is N, and since it has 0 charge, it is to the 0 for that symbol. And it's also located in the nucleus. Then lastly, we have electrons, which have a negative charge. They have negligible mass, so their mass is not significant, so we just say that they have 0 AMU for their mass, and their symbol is an E with a minus sign, and they are located in the electron cloud or the electron field. We need to learn a bit of vocabulary for this unit, and so the words we're going to be learning about right now are going to be atomic number and mass number. So these are numbers that will help us understand atoms. So first we need to know what particle determines the identity of an element. So when we added that into our built-in atom, it's the one that determined which element was created, and that is our proton. So when we had 1 proton, that meant that it was a hydrogen atom. With 2, it meant it was helium, so on and so forth. So the number of protons determines which element an atom is of. So that means that our atomic number is just going to be that number of protons. So the atomic number is going to be the number of protons in an atom. The mass number is based on those 2 subatomic particles that impact that mass number that you saw in the lab, and those were the neutrons and the protons. So the mass number is going to be the number of protons plus that number of neutrons, and that will give us our mass number, since those are the 2 subatomic particles that have a significant mass. What about the charge that we saw in that built-in atom simulation? How can we find that overall charge of an atom? If an atom is neutral, that means that it has the same number of protons and electrons. Any difference in charge is going to be based on a difference of protons and electrons. So an easy way to find this is you can simply take the number of protons minus the number of electrons, and that will give you the charge. So if we have a helium atom, it would have 2 protons, and if it's neutral, it would have 2 electrons, and that would give us a charge of 0. But say we have a fluorine atom and it has 9 protons and it has 10 electrons. That would mean it has a charge of -1. Alright, so what subatomic particles are lost or gained in a chemical reaction? That is our final question. You'll be learning about this later in chemistry, but the only ones that are lost or gained in a chemical reaction are the ones outside of the nucleus. The nucleus will not be changed by a chemical reaction, so only the electrons will be lost or gained during a chemical reaction. Here are some photos from that built-in atom lab, now with the isotope symbol. You'll learn more about isotopes in the next video, but for now, we're going to talk about the symbol. This symbol includes the mass number, the atomic number, as well as the charge. So let's go through each subatomic particle and see which of these it changes. So here with the proton, it changes all 3 of these. It's going to change this one on the top, this one on the bottom, and the charge on the right. Then the neutron, if we just add 1 neutron, it just changes the one on the top. It doesn't change the one on the bottom or the one on the right, so it doesn't change the charge either. Then lastly, we have the electron. All this one changes is the charge. It doesn't change the one at the bottom or the top. So now we just have to think which one is the mass number and which one is the atomic number. So the mass number will be changed by both neutrons and protons, and the atomic number will only be changed by protons. So it's safe to assume that the top one, that's changed by both protons and neutrons, so the top is going to be the mass number. It's going to be on top. On the bottom is going to be the atomic number. Here is our hydrogen. And then the charge is going to be right here if that atom has a charge to it. That is an isotope symbol and how we write it. We can see this in these isotope symbols here for hydrogen. Here are 3 different kinds of hydrogen with 3 different mass numbers, and that's because each of them has a different number of neutrons. We start with 1 proton, and that's it. We add a neutron, so now it has a mass number of 2 and an atomic number of 1 still. And then lastly, we add 2 neutrons, which gives us a mass number of 3 and an atomic number of 1. So that is how we write those isotope symbols. Then on the bottom is the isotope name, which includes the name of the element and its mass number. So now let's put it all together. We've learned about isotope symbols, mass number, atomic number, and then how to find the number of each of these subatomic particles. So let's start with uranium-238. We know that this number at the end is that mass number, so we can just plug that right into our chart, 238. And then now we can write that isotope symbol because all we need is the mass number and the atomic number. Mass number being on top, 238, atomic number on bottom, 92 with U as the symbol for uranium. And now we can go on to find that number of protons and electrons. So here our number of protons will be the same as our atomic number, 92. And if it's a neutral atom, it's going to also have 92 electrons. Let's try one more, and then I'll let you pause and try the rest. Here we have uranium. It has a mass number, as you can see in this isotope symbol, of 235. So I'm just going to put that in the mass number section, 235. And now I can also write that with the isotope name, uranium 235. And now we also have the number of protons. So that gives us the atomic number, 92. And then the electrons are also going to be 92 since they will equal out. And then lastly, we need to find the number of neutrons. So what 2 things do we have that could tell us that number of neutrons? Well, if we look at this hint at the top, the first thing tells us that the mass number is equal to the number of protons plus that number of neutrons. So we can just plug these things into this equation. Our mass number is 235. That's going to be equal to our 92 protons plus our neutrons. So if we just subtract 92 from 235, we can get that number of neutrons, which is 143 neutrons. All right, you've got this. Good luck with the rest of those, and feel free, review these notes, write everything down on your note catcher so you can have it forever.